Hello everyone, welcome back to another new live stream. Today we of course are gonna do the part 4 of the antivirus evasion from Cocomelon C. We will analyze it as always, and if we have time we will go to part 5 as well. Firstly, before we start anything, I would like to say thank you for watching. If you have seen the previous streams, I will try to explain them like now every every single one of them like fastly, like quickly, so you have a basic idea of what we're doing. Also, give me 1 second to check my sound if it's good. Okay, it works perfectly. Excuse me. So what are we gonna do today? As I said, today we're gonna see again the part 4, and we will briefly explain the part 1 through 3. So in the first part we create a payload. This is a payload for a calculator. This will just open a calculator. If we test it, I think it was the A. It just opens a calculator, a basic calculator. We essentially put the payload here. We also assign to a variable its length. Then inside the main function we allocate some memory enough to hold the payload. We copy it to the buffer. Then we change the writes from read and write to execute and read, and then we create a thread that will be able to execute it. A thread is like inside the threads inside a process, and then we wait until there is space enough space inside the CPU that can execute it. Then in the second part we did the exact same thing, but we did add some things. We add obfuscation. We used XOR, the XOR encryption. We essentially just allocated some. We initialized an array and its length. We used a secret key. It's like meow meow. That's our example. Then we initialized a pointer to the virtual alloc so that we would not raise flags with the virtual alloc. This is essentially virtual alloc, but this is just a pointer to virtual alloc. Then we have the XOR algorithm here. The XOR, the XOR. This is to decrypt the XOR. Then inside we initialize the main. Again, the same stuff as in the previous one. Then we XOR the virtual alloc with length with the secret key. Okay, what? With the secret key and its size, we did the parameter, the data, its length, the key, and the key length. And essentially we just do XOR for all the data. As I have explained, let me do it fastly. Blackboard online. No, why, but I like the blackboard more than a whiteboard. Come on. We'll give it a sec. It's the exact same thing. The only difference is we XOR. Then we allocate memory to the buffer using the get module handle and the DLL that we want to use. Is it right? Yeah, okay. So XOR, if you don't know, essentially it would take the input, like for example 00110, and if we XOR it with itself, for example, we would always get 0 because 0 0 it gives 1 if they are different and gives 0 if they are the same. But if it's like 0 0 1 1 1 and the other one is 0 1 0 1, this would give us 0, 1, 1, 0, but this would give us like all zeros. That's the XOR way. It's a pretty simple. We allocate memory buffer for payload. We get a handle that we get like a handle for the module, and then we get the address of that process, and essentially this will allow us to have the virtual alloc without it ever being called, without it ever being seen from the program. Then we initialize the memory, which is gonna take the peri-virtual alloc. It's the same thing from here. Then we copy it to the buffer again. We add protection, like the same. We do actually just add execute and read. Then we create a thread, and then we wait for the single object. Why did I do that again? And that's ready. I think we can execute it. It is a part 2 malware. I think it was the evil actually. Was it? Let's just gcc the malware v2, and we will have it as let's do like good.exe. Oh yeah, we got this error, that's why. We had this error and I don't know how to fix it. I think permission is the way, minus f permissions permissive. But then we got another error. Well, yeah, I was like, yeah, I cannot just find out why right now. I forgot to actually search how to do it. And we also did have a Python file that just encrypts the data, and here this decrypts the data. So this will create a new file. It was the evil encrypt. It is the exact same, but the payload is changed. If you see, it starts from, where is it the same? It's the same. Why is it the same? What was changed? I forgot. Oh, the payload here. And here it is empty, but actually here it is changed. Oh yeah, this is the payload for the virtual alloc. So this will XOR and encrypt the data and actually give us the payload for the virtual alloc. And I tried to add another one for the virtual protect, I think, but I just didn't want to spend too much time right now. I might do it alone and I will explain it, but that's for another time, at least for now. And what should we do? Okay, now there was the part 3, extremely similar, but it started a different way. Instead, we used the Windows API of pvirtualalloc x NUMA. We initialized the check NUMA. It was to memory allocate work on regular system to fail. This what checks? Checks for what? Get current process. I think this checks if it is an emulator or like a sandbox. This checks if this is a sandbox. Right. Or if it checks, I don't remember. Here it checks the resources, like if it is less than 2 gigabytes of RAM in here, and if the CPU processors are less than 2 again, it's like it is safer to say that it is a virtual machine or a sandbox. So it just set itself up. And then inside the main we do have a payload. It is a message box. it seems awfully familiar with the other one. Like this. It's not the same. Yeah, it's not the same. It's similar, but it's not the same. In the future, I will make a video where I will explain all of them shortly. Now I'm just doing a quick recap. I don't even remember all of it because it's been like a week or something. We use the process ID, the toy. I don't remember what a toy even does. Let's search it. A toy in C. Convert a string of characters to a value, to an okay. Okay, then it takes the executable. I renamed it meow, and if it's null, it says what's my name. Else it returns -2. Else it continues. This is just all checks. These are there? I think they're below. No, those are like inside the library. If it's debugger present, then we again automatically shut down. It checks if the memory allocation has failed, and we also check the resources. Yeah, okay, let's check the. Which one was it? It was this. I want to check it because I don't remember it fully, so it would be better if I saw it. Reserve committer changes the regional memory within the virtual. Okay, so this just checks. This does the allocation as usual. Okay, so this is, I think, almost the same thing as we did here. Not here. Yeah, it's here. Essentially, we use what in here. Okay, it's the same as in here. It actually just gets the process that we want, like the virtual alloc, and we just give it another name so it is undetectable. If we use the strings command, strings, is there thing I can use it, strings to the malware v3 meow dot exe. Okay, it give us all of the string inside. We see the meow meow, sandbox, the messages, virtual log. We see that there is the kernel 30.dll, the virtual log x enuma, but we don't see what's called. We see that it's a string here, but we don't see what we don't see. It's probably not gonna be called. It's probably if we use in the P file. I don't actually remember. I should check it out. Okay, I will make a separate video where I will have seen again. I will analyze everything together to just move on now because I'm gonna lose my mind. This post is a result of my own research. Yeah, I simply learned how to bypass. Okay, this trick regarding how you hide your Windows API calls for static analysis. Okay, static analysis is a part of the malware analysis done. Essentially, in the static analysis, a defender will try to understand the code without actually executing it, like using the PE-bear or other tools that will not execute it. When the execution is called dynamic analysis. When you want to interact with the Windows operating system, you call Windows API, for example, user OK from your code message box. Okay. What is ordinals? Each function export by DLL is identified by a numeric ordinal. Unofficially named, Likewise, functions can be ported from a DLL either by ordinal or by name. Still don't understand what is an ordinal. Rank or order, okay. Numeric ordinal optional name. Likewise function, okay. The ordinal represents the position of the function address pointer in the DLL export address table. One of my previous I wrote a simple Python script which enumerates the export functions from the provided DLL. I have not seen it, but let's copy it anyways. What does it do? DLL diff.py. DLL def.py. So it imports the P file, sees an OS path. In the DLL it uses the P file. This is like the P file will show the data in hex form. P file Python of the portable executable. Okay, the P file is a portable executable. I always forget what it is. Okay, this allows us to inspect headers, analyze it, retrieve. Okay, and in here he gets the P, the portable executable, from the first argument, and then the base name. He's gonna split the. He's gonna take the first argument and says take the first one, which is gonna be the name, and he will try to open it. First, he would like to split it from the slashes, like in here there are slashes, and it will try to replace the DLL with the def. So instead of .dll, it will have .def, and it will write it. So this will override the DLL with def. As a file, it will write exports, and exports in DLL directory entry and symbols. And in here, if the export.name, if this is true, so if this is not a null, it will write the name, decoded, name, decode, and the ordinal. It will print if this fails, then it's gonna print it failed to do it. Otherwise, it's gonna give us a successful message. Let's try to run it. Okay. Python DLL user 32 DLL. Do we get anything? Don't see anything. But successfully, he does get the message. I get no message. Did I forget to? Yeah, I forgot to actually pip install p file. I forgot to save it. That's why it did give me nothing. Why I cannot find user32.dll? Let's do kernel 32.dll. Kernel 32.dll. Okay, cannot find it. Let's just make a dummy one. That's user 32.dll. There is no touch. How do you create it? Touch in Windows. Copy. That's not recognizable. how to create a file using cmd. Dear cd mkdir, this makes a directory. I don't want to make a directory, I want to actually just create a simple file and rename it. Let's do notepad user32.dll. Let's just do this, save it, and let's run the Python script, not with the kernel, the user, unable to read the DOS header. Okay, so this needs to be where is user32.dll located? Amazing. Let's go. Oh, I think I need to be as an administrator. Yeah. Dear. Okay, yeah. It's probably okay. Let's go cd. So we can dear users. Cd users, cd dear, cd sum, cd desktop, cd testing, and we copy from Windows system 32 user 32.dll. No. Oh, here, yes. Okay, let's try to open it. Notepad user 32.dll. Yeah, okay, so now it's an actual file. Boom. Oh, it's failed. Why? Why did it fail? Let's try to actually do it again. DLL and user 32.dll. Failed to create a dev file. Is there a reason? Let's go to the CMD and try it again. Failed again. Okay, so essentially which one can it not do? Let's in here print hi. It doesn't even go inside here. Let's again try this. Okay. Is the list going here? Yeah, it does go in. It tries this. What if we do like this? Okay, let's move on kindly. He cuts and grabs the message boxes. This is all done in Python. As you can see, for example, for message box, ordinal, yeah. Where do we see it? Okay, the message box A is this, and the XA is the next one. 46 is the message box W. Okay. Practical exam. Let's look at practicals of the ordinals might change on its release of the DLL. We do not hard code it in our code. Okay, so what he's saying is that in this version of the user set DLL, the message box A is like 2039, and in the next year it might be like 2041. It's different. So what we don't want to do is actually be like, oh, 2039 is always gonna be message box A. No, we want to rate it first. This kind of productive. Okay, the technique is very simple. First of all, I used a trick from my previous post. This is the payload for the message box. This is the module for the 32 DLL. This is the shell code, if you want to say it. Then the key, and then XORing it. On my Python script, I think it is the exact same thing as in the previous one. Yeah, it's the same thing. Instead of doing the loop, he just gives the name directly. The plain text is gonna be this. Instead, we do like what we want. In our case, yes. In general, we use the name pointer table mpt and export ordinal table to find export ordinals. So I used function for get export table primary export directory because we will be able to find it in the Windows 30 Windows. No. Okay. Export directory table. What is that? Cool name. Again, he understands it. This is his code. Sorry for like going out on my way. Okay, so he uses like the assembly code. XOR 0 this X. He gets to the X, the PB. Okay, he does a bunch of stuff. Most of them I don't understand them. I mean, I I don't understand how that means that. The base pointer, yeah, it is the ABX, and the ABX is the destination. The get proc address, this is the destination. No, this is the register. Those were both registers actually. Those don't mean anything particular. It's like ESI or ESI is the source index. He gets memory. Yeah, I don't understand how okay, I will search it in the future. I will tell you. So this is the payload. He gets a handle. I think this is get console window. He will show that window, he will allocate the memory, he will copy it, and then he will execute it, and then he will return 0. Okay. Sorry for for wasting some time, but this is actually very interesting. Have I seen him before? It seems awfully familiar. Huh. It seems awfully familiar, but... Well, I will see him in the future, so let's just ignore it for now. He will get the base address module, conf file header. What is that actually? Conf file header. Common object file format, okay. He will get the file header of the common object file header. Export the directory table. What's the difference between this and this? Don't know. D word of the RVA, double word, DOS header, optional headers, and the signature. Okay, I don't understand most of this. What's all of this? Oh my god. Oh my god, my brain is being fried right now from all of this. Okay, let's take it step by step. Export directory table. Start the base of the module. The MS-DOS tab begins here. This is the base of the module. This is the DOS header. As we said, if we open the pbear, set open pbear, let's load let's actually do this. We can see the sections here. The DOS header, which we said is this one with the magic number. This is the DOS header. The optional header is here. I don't know why it exists. It just exists. And then the signature, file header. There's also a file header. Here, there is no file header here. No, there is the file header. Then here's the base of the pip module, then the DOS header. He gets the signature and verifies it. This points to the base plus the image DOS header, which points to EA alpha new. Then it checks if the image signature is different from the SIG, and if it is, it returns no. It says like it's a bad signature, so it needs to be the same as the signature. Then the image file header is given the value of the file header plus the signature plus 1. What else? It gets the optional header. So this just gets the information from here. It gets the header, the optional header, and the signature. Here the file header is right here, the signature in here. This is the base, and the DOS header, the optional, and then finally it exports the directory table. What's the directory table? Directory table. Which one is the directory table? Is it this section, the whole section? Okay. It checks if its entry point is bigger than the opt header. If it is bigger or equal, doesn't have an export, so this needs to point to here. This is the entry point, then it gets a header. Okay, insert some name pointer for the name procedure. dword find func b. This is searches in binary. It gets some parameters. What is p dword? Dword is WP dword. Pointer to a dword. Okay. Then it compares. Then the max, mid, and main. The minimum is 0 and the max is 1. If the minimum is less or equal to the max, it does a binary rotation thing, right? Binary rotation with 1 byte. It compares the NPT, the mid plus the base with the proc. It should print a message here. If it's lower than 0, then it's going to mid. This is like, it's like, oh yeah, it's binary search. It's like the searching for the middle value. It's like bubble sort but different. It just compares it. This is like compares it if it is below or above, and if it is above it goes lower, and if it is lower it goes above. I don't know if that made sense, so let me try to show it. Again, I think that's it. I'm not 100% sure, but I think that's correct. If this comparison, if it's lower, then it goes to mid plus 1, else it goes to mid minus 1. Okay, so it just divides it all the time by 2. So let's assume that there is the value you want is here. For example, it just divides it into the middle, and it searches and it asks, is this value above this? Yes or no. If it is, then it starts from one above, from the exactly one above, and it does exactly the same search. And again, it searches in the middle. If it is, then it stops. If it's lower, it goes one out below, and if it's higher, it goes one above. It's that simple. Finally, it gets the ordinal, gets the function ordinal. I don't understand how any of this works. This he XORs the DLL and the MB. Why is there MB? It loads the library as DLL. It gets the module. It's a handle module. Then the ord it calls this. And then we get the message box with the classic get proc address with the module and the make interest stored. Then the message box is gonna show meow meow and okay. And his full code is this. It's essentially all what he described above, everything in one code. And he tries to execute it. He gets a node. Let's actually try to copy and paste it. I don't understand the code, to be honest with you. I don't. Do I want to understand it? Of course. Do I understand it? No. At least you can say that I'm honest, that I don't understand a thing. Not a thing, I understand some things, but the least of the things. Was it C or C++? It was C++ probably. Right? Yeah, C++. Then he uses this. Let's change the hack with malware v4. It's not required, so we can use just C++. Did we get a hack? No, we would do just this malware v4. We didn't get anything. Why? Oh, it just deleted the a.exe. Sir. Oh, do I need to change that? Oh my god, I do. Where did I download? I think it was in the bin here, not here. Here, Mink 64, and include. So this is the one. Let's change this to this. Okay, let's use the backslash. Okay, again. If we completely remove it, or if I just remove the no. If we remove it, let's just try to remove it. Again, file format not recognized. What if we use GCC instead of G++? Will it work? No. Undefined win main. But there's a comment here. Let's just try GCC malware v4. Okay, I still don't know why I get some of this error. I don't. Why? And he executes it, gets the message box, As you can see, everything was prepared, but for purity of the experiment, he added one line in his program. If it is -1, it says that it failed, and it prints the message. It just prints the message of the ID of the ordinal ID. As you can see, our mark was successfully string. You can see no message. Okay, let's upload virus total. He gets 6 again, and that's everything. Damn. Yeah, this is part 5. I don't think I'm ready for the part 5 right now. In each one he gets much better, much faster, and my brain. In the next one we might stop from the antivirus, at least for now. I really like this Linux hacking. For example, this is a keylogger. Let's search for the other ones. Linux hacking part 4. Linux, where is Linux hacking? I probably missed them. Part 4. What's this? MD second edition Cocomel. Oh, he made a book. Damn. Oh, he has a daughter. Okay, I don't know if I should actually show that. For those reasons, I will not. Malware dev tricks and device tricks persistent malware. Okay. Of course, everything is in blogs. His books goes okay. If anyone said he's doing great, you should buy his book, in my opinion. He will say, if you are unable to pay for it, I will send you for free. What? No, I don't want it. That's fine. He's just doing. He's a great guy. Don't know him, but I look forward to finishing all of these parts. I will eventually. Linux malware dev is kernel hacking. This seems really interesting. I mean, we can try it. We can try it for a change. Malware is in the wild book. Give me one second. Okay, and I'm back. Let's see again. I mean, everything that he promotes, I think it's for a good reason. So if you want, you can definitely check it out. I hope in the future I'm able to afford it, since now I'm in uni. I don't see the Linux anymore, so he might have just renamed it. Oh damn, malware antivirus he has. Oh damn, 16 parts. I never knew that actually. Malware. Oh, he has 8 parts on malware analysis. Okay. Something reminds me of Mutex. Let's see, what is Mutex? Oh yeah, it was in something in the OS. It's like it was. I think if I'm not wrong, it was created in order to um, for processes together to not or threads mm, to execute independently. So a process would be executed and nothing could stop it. Um, Nothing could stop it, at least for a bit. I did it. It was like a Unix class, and I passed it. That's why I'm like, what? It was the mutex was something that paused the project, and no other could actually execute while it was in that mutex in OS. It prevents multiple third persons for simultaneously accessing shared resources. Yeah, so essentially it blocks a lot of resources, a lot of threads or processes from something in common. So if something uses like one CPU process, one CPU uh, resource, another process cannot use that same thing until it is done. So mutex essentially blocks the other processes from accessing the first CPU core. Okay, I'm really excited because there are a lot of parts, both in malware analysis development, in C, in Python, in Linux. I'm not an expert, of course, but this seems super interesting. Also, the advanced persistent threads. I will definitely, at least for now, we will do less things and try to understand them. But in the future, I will definitely do a lot more. Anyways, thanks everyone so much for watching. I think it was a fairly shorter and less explain video. But again, I don't understand everything. I'm trying to learn here together, and I'm here to share my journey. Although I don't understand everything, I will try to understand most of the things, even if it is by time, persistent, or anything. So, again, thanks so much for watching, and see you in the next one.